morning, students. How is everyone? As you know that we have started chapter number 3. Okay, and yes, what is the name of the chapter? The atomic structure. And what will we do in it? We will see the various topics. We will see the various experiments which were done by different scientists just to reveal the structure of an atom. In this regard, the very first scientist was Dalton. He proposed, he put forward his famous atomic theory. It was done day before yesterday. Then we have seen modern atomic theory. Then yesterday we did what? Different kinds of atom. So what was the summary of Dalton atomic theory? According to Mr. Dalton, each and everything is composed of what? Each and everything is composed of indivisible, indestructible particles called atoms. So according to Dalton, atoms can't be destroyed. Atoms can't be created. Alright? What was the second point? Atoms of one element are exactly the same. Suppose you have a piece of iron, then all the atoms in that piece of iron would be alike in all respect, would be identical in all respect. Okay? And what else? It's common sense that if we have two different elements like iron and copper, then the atom of copper will be totally different from the atom of iron. So on. Point number 3. What was the point number 3? That when atoms combine in a simple ratio, they form compounds. Like in water, 2 hydrogens combine with 1 oxygen to form water molecule, and so on. Okay. So what is the point here? Atoms combine to form compounds in simple ratio. What was the point number 4? Point number 4 is that you cannot create matter, you cannot destroy matter, or any chemical reaction. There isn't any production or destruction of atoms. Then what happens? In all chemical reactions, only rearrangement of atoms is there. Suppose you have alone a piece of carbon. Suppose you have some oxygen. Then when you react them, they will form carbon dioxide. Now they have rearranged themselves. Now they have built a relationship among them, a bond among them. That due to this, we call it carbon dioxide is formed. So in the formation of carbon dioxide, for example, there isn't any production of carbon dioxide molecule. No, it's the rearrangement, restructure, reframing of carbon and oxygen. All right. Then we have studied the correction of Dalton atomic theory, and after that we know that the atoms can be destroyed, atoms can be created, and so on. That we have studied in understanding of modern atomic theory. Then the various parts of an atom that we did yesterday: nucleus and extranuclear region. In nucleus, we can find all the particles except electron. Electrons revolve around the nucleus in various shells, like planets revolve around the sun. Whereas in the nucleus, all the other particles reside. They live inside the nucleus. What are the particles? Protons, neutrons, neutrino, antineutrino, electrons, mesons, bosons, big boson particles. Number of particles are there left. Alright, all there in that small, tiny, little nucleus. Alright. Then we have gone through what? We have gone through the various properties of these electron, proton, and neutron. You know it very well. The electrons are negatively charged. You can find them around the nucleus in orbiting. But the lightest particle, mass is this one, charge is this one. Then what is the symbol of proton? E plus. It is positively charged. We can find that a proton in the nucleus. What it is heavier than electron. How many times? 1836 times. It has a particular mass and a charge equals to the charge of electron. I'm talking to those especially who were present yesterday. If you were absent yesterday, it will be difficult for you to go with me right now because I'm a little bit faster. Okay? Neutron, no charge, neutral particle. It is also called standard because 1837 times heavier than an electron means it is the heaviest one. Among electron, proton, neutron, neutron is the heaviest one, electron is the lightest one. And that's all. Now let's begin today's topic. What can you see on the screen? Yes, neon signs. You must be remembering. You can see the various use of neon signs, like for the number plate of a vehicle, for advertisement purpose. Then you can see also an old television, TV. Then tube light, and then television with circuit. And the upper one, the TV, can be used as a monitor for the desktops, computers. So why are these here? Why am I showing you all of these neon signs, tube light, CRT, cathode ray tube? You know it. CRT is also called monitor. Why? Because today we are going to study what is the reason behind this. So this is the topic that we are going to start. What is the topic today? Discovery of electron. How electrons are discovered. It means whatever you have seen is related with this topic, with the discovery of electron. What are the other names of this topic? Discovery of cathode rays, right? Or Crookes tube experiment, or discharge tube experiment, or Giesler tube experiment, or testing of electricity through gases at low pressure. All of these are the various names of this topic. Alright? So, discovery of electron. Now, today we know that an atom has electron, proton, and neutron. Before 1895 or 1890s, or you can say in the last quarter of 19th century, the concepts were different. And in the last quarter, especially in the last decade, the whole science, physics, chemistry, biology, all different branches of science, there was a radical change. There was a basic change. A thing, a phenomenon, something very, very strange done. What is that? This experiment. Due to this, the science has been changed. The whole science, the fundamental of science changed because of this experiment. Okay? What was the concept before this? You can't destroy atom. You can't divide an atom. But after this experiment, the scientists came to know that they can divide an atom. They can split an atom. Alright? And this is the first particle that discovered inside an atom is an electron. Okay? So discovery of electron, it was done by Sir J. Compton. There is a short homework assignment for those who have interest in such level. What is the full name of J. Thomson? Just message me afterwards. It will reflect your interest. So, who discovered element? Sir J. Thomson. When? In 1897. Here is Mr. J. Thomson, a learned person. Alright? And what is the name of the experiment? Discharge tube experiment. He used an apparatus that we call discharge tube to perform his most famous discharge tube experiment. Alright? So let's see what he did. What he did. Here is the discharge tube. Let me show you on the screen. I'm sorry, on the board. Look at the board. A tube. Wait for a minute. What is this? A tube light. Right? A tube light you can see. So I'm going to draw this tube light over here. This is the practical form of this experiment. Okay? This is the practical form. So we have a tube, glass tube. Alright? This glass tube is sealed from both of its ends after removing air from inside it. Means it has very, very less pressure of air in it. Very, very less pressure. The normal pressure that we are having on our body or any other thing is 760 torr or 1 atm. These are the units. You are not going to remember all of these, the units, but just for the weightage, I'm telling it to you. So, what is the pressure right now? 760 torr, 760 millimeter of mercury. All right. Now, what he did, Mr. J. Thomson, this tube was invented by German glassmaker Henry Giesler. That is why it is also called Giesler tube experiment. Okay. So, what he did, W. Crookes has also some contribution in it. That is why it is called Crookes tube experiment. So, what he did, he connected a vacuum tube, a vacuum pump. Now the question is, why he connected? What was the reason behind his curiosity? At that time, scientists were able to pass electricity through solids, like they have passed electricity through copper wires, through iron, through metals, through solids they have conducted with electricity. They were also able to conduct electricity through solutions. Recall the movie, The Three Idiots. First scene, the three students were there first time inside their institution. They were locked inside the bathroom. And then what happened? Recall that scene. So, liquids, solutions can also conduct electricity. So, in that era, it was confirmed. What was the confirmation? That electricity can be passed through solids, electricity can be passed through liquids, but they were not able to conduct electricity through gases. Gases do not conduct electricity under ordinary conditions. So they were performing a lot of experiments. So in one of the experiments, what he did, he took a tube and he fixed a rod over here and a rod over here, a metallic rod, you can say, or inside the tube. When you if you break it, you will see that there is a metallic rod over here or over here. It could be a rod, it could be a flat rectangular shaped piece of metal. All right. So in any case, here we have on left and right we have two pieces of metals. These metals are called electrodes in this practical. So here we have an electrode and here we have an electrode. One is connected with the positive side of the battery and is called anode, and the other one is connected with the negative side of the battery and is called cathode. So what is the situation right now? A tube, a glass tube, a vacuum pump is there. Why? Because he wants to decrease the pressure which is inside this tube. So he started the vacuum pump and then the pressure inside the tube has started decreasing. And then in the tube we have they had an electrode over here and electrode over here. What do you mean by electrode? A piece of metal. Okay, like if you might be have some guys have done it. If you take a normal battery cell like Toshiba or Canon, etc., if you break it, you will find a central black colored rod. That rod is a cathode. That is made of carbon. Okay, and then he connected these electrodes with the positive and negative side. Positive side electrode is called anode. Negative side is called cathode. All right. And then what happened? When he connected with the high voltage, he saw that some bluish color started flowing from left to right. Okay. Cathode is negative side, anode is positive side. So they are seeing that cathode, the rays are producing from cathode side and traveling towards the positive side. If I summarize this topic, a glass tube fitted by a vacuum pump, having two electrodes inside, and it is sealed. The two electrodes are connected with positive and negative terminals of the battery. The one which is connected with the positive terminal is called anode. The one which is connected with the negative terminal is called anode. When he applied high voltage current, what happened? Number of phenomena they have seen. But that some rays are producing from cathode and moving towards anode, bluish green rays. These rays are called cathode rays. Why are they called cathode rays? Because it is producing from the cathode side. Okay, from the cathode side. It is producing from the cathode side. That is called cathode rays. Later on, scientists came to know that cathode rays are actually composed of what? Tiny particles called electrons. Now the question is, from where the electrons have come? The answer is the atoms of gas is present inside this tube. That those atoms split, those atoms divide, breaks, and they ejected electrons. So what is the bottom line here? Atom is divided, and you have got the very first part of atom, which is electron. So cathode rays are actually made up of what? Electrons. Okay, so this was the summary. Let's see on the screen. So as I have told you that you can see a tube, a rectangular, rather cylindrical type tube. Inside the tube, you can see two rods, red colored rods. One of the rod is connected with the negative side and is called cathode, and the other one is connected with the positive side of the battery and is called anode. You can also see a vacuum pump. So what are the main parts of discharge tube experiment? A glass tube which is made by and reduced, a high voltage source or battery, a vacuum pump. What is the purpose of vacuum pump over here? It is used to evacuate, to remove, to decrease the pressure of the gas inside the tube. Okay? The tube has some gas, any gas, it could be filled with any gas. And when you connect it with the vacuum tube, the pressure inside the tube will decrease. Now you have power of electric current. After passing electric current, what happened? The tube is evacuated and a high voltage of electric current is passed. What was the observation? Bluish light, greenish blue light appeared between the two electrodes, and later on it was seen that it is traveling from cathode to anode. Like this. Okay? Then as I told you, these rays appear to travel from cathode to anode, means they are traveling from the negative side to positive side. This was the first observation. And second observation, after reaching to the opposite side, to the anode side, when they hit the wall, they produce fluorescence. They glow where they strike. So what is another point? What is another observation over here? That when these rays hit the ball, they glow. Okay? There is a certain condition. The wall should be covered with a chemical like zinc sulfide. I repeat, the wall is coated with, the opposite wall is coated with zinc sulfide. So when these rays hit zinc sulfide, they produce fluorescence. And in this fluorescence, we call it that the tube light is glowing. That the tube light is producing white light. So if you had an experience to observe a broken tube light, you have seen that the broken tube light, the inner wall of the broken tube light is coated with a powdery white colored powder. That powder is actually zinc sulfide. So when these rays hit with the wall, they glow. So this was an observation. Next point, what have I written? These rays were called cathode rays. Why it is called cathode rays? Because it is producing from the cathode and moving towards anode. Later on, they came to know that these rays actually consist of negatively charged particles, which later on named as electron. Okay? So in this way, electrons were discovered. Summarizing, what is the name of the topic? Discovery of electrons. Okay. J.J. Thomson, 1897. Discharge tube experiment. Contributions by W. Crooks, and Giesler is the German glass maker. The tube has two electrodes, cathode and anode, connected with a source of battery, high voltage battery around 10 kV, 10,000 volt, and a vacuum pump is there to reduce pressure inside the tube, to reduce pressure of the gas filled inside the tube. When all is done, then a bluish light appears, radiation appears, rays appear, and they appear to travel from negative side to positive side, from cathode to anode. These rays are called cathode rays, and they are composed of electron. I hope you understood it. Go through the topic in your book. You can see the actual picture over here. Something appears like this. And just for info, there are different forms of discharge tube. Like all of these that you can see, all of these are different kinds of discharge tubes. On left side, you can see J.J. Thomson performing this experiment. You can see little right side, little discharge tube. All of these are discharge tube, various discharge tubes. And all are there. The discharge tube is mounted on a non-conductive stand like wood or etc. All of these are different types of discharge tube. You can see the arrangement. Okay? So Mr. J.J. Thomson resulted. Alright, we got to know the prize in engineering course 6. So that's all for today. Tomorrow we'll continue with the properties of cathode rays. The topic is not finished. These are tomorrow's topic. What will you do tomorrow? What is your homework? Just go through the topic from your book. Just go through the topic from your book. That's all for today. Okay? No other homework. Just read the topic from your note, from your reference book, from any other book. Take care. Love you.